Welcome to this demonstration of global sustainability analysis in Cosmic Frog. This global sustainability model features a manufacturer's supply chain with a network of production plants in Asia and South America. Here we have the baseline map of this global network. Plants in China, Vietnam, and Brazil flow goods into the distribution center in Detroit and out to customers throughout the USA. This baseline network forms the foundation for our scenarios later on. In addition to balancing financials, service, and risk, the goal for this analysis is to find the most sustainable supply chain. We will answer questions like, can I reduce my carbon footprint without significantly increasing costs, and look at other sustainability questions. Before we get started, let's look at the data that powers this analysis. Here we have the Anura data schema. This includes core supply chain elements like customer and facility locations, as well as business rules and policies. In the facilities table here, you see the plants, ports, and DCs. We have helpful tooltips to guide you with what information is needed. Since this is a production model, we also have bills of materials. Here is where we go beyond traditional supply chain elements and include sustainability elements like water consumption and packaging that goes into making the finished good. How do we source the CO2 emissions data? There are a few options. If you have the data already, you can use your own. If you need to find the data, there are several third-party providers with emissions calculators. In this example, we used Optilogic's platform extensibility to connect via API to a third-party provider. This provider generates carbon emissions factors based on origin, destination, vehicle type, and other arguments. The result of this API call automatically populates the coefficient column. The unit of measure here is in tons of CO2. Now that we have input data populated, we can run scenarios to ask what-if questions about sustainability. With the Scenario Manager, we can quickly turn off or on different model elements. We can use scenarios to change modes, change demand, and change sources. And here we're creating some scenarios to include China only, Brazil and Vietnam only, as well as a maximum emissions cap of 1.7 million tons of CO2 as a constraint. Additional scenario options include testing out alternative packaging options, like using a different packaging material or a greener production process that consumes less water. Next step is running our scenarios and choosing our resource size. I ran all 4 of these scenarios on a medium resource. After running our scenarios, we can begin our comparison on the map section again. Here we can compare all 4 of our scenarios from a product flow, sourcing, and distribution perspective. We started out with the baseline, and now we look at the China-only scenario, where you see that our manufacturers in Chengdu and Shanghai are the only manufacturers producing in this scenario. Alternatively, we can exclude China and only source from our manufacturers in Vietnam and in Brazil. We can also get our answer to what should the network look like if we put that carbon emissions cap on the network. In this case, we utilize our manufacturers in Shanghai and in Brazil. We can also learn valuable information about risk on the map. Here is a natural disaster risk score by location. Green is low risk, orange is medium risk, and red is high risk. This risk profile is an important part of climate analysis, but because it includes the risk for climate-related weather events like droughts, floods, landslides, and cyclones. Now we move to the scenario comparison, which is the overall summary of cost, service, risk, and greenhouse gas emissions. From a cost perspective, if we move from China only to just Brazil and Vietnam, production cost jumps from 33 million to 39 million, but transportation cost falls by $10 million from $69 to $59 million. The production cost trade-off here is outweighed by the transportation cost savings. From a greenhouse gas perspective, the China-only scenario results in 1.8 tons of CO2, which drops to 1.5 tons of CO2 when we move to Brazil and Vietnam. Service is equal across all scenarios. And then we take a look at our risk metrics. We see that it is riskier to drop from 4 plants to 2 plants because of that concentration risk. There's less backup options when we condense and consolidate the manufacturing footprint. Next, we can dive deeper into the production summary. Here we can see the number of units produced at each plant and the production costs. We can also learn about the consumption of cardboard packaging and water in the production process. We can look at total consumption of cardboard and water. As a final step, we can look at our risk analysis with the facility risk summary. Here we report the results of the risk engine, which include internal factors like concentration risk and external factors like geographic risk. Included in geographic risk are some common sustainability metrics like economic risk, natural disaster risk, and labor risk. And you get this breakdown score for each of your locations. You just saw an end-to-end demonstration of how to incorporate sustainability into your Cosmic Frog models. We brought sustainability input data, including CO2 emissions. We built and ran sustainability scenarios, and we brought sustainability metrics to our analysis. We invite you to try these techniques for your next supply chain model.